Alex, and I would like to right now invite our panelists, but before I do, this is a space inclusion session on lean satellite technologies and how they can be used in solving or helping us to achieve the sustainable development goals. Our panelists today are from academia, enterprise, and regulation, and we will hear different angles, but everything is aiming at helping us understand better what is space inclusion and what is lean space technologies, but even more importantly, how do they actually solve people's problems. So I'd like to straight away invite Professor Shinichi Nakasuka, professor from the Department of Aeronautics and Astronautics, School of Engineering, University of Tokyo, to take the first seat. And I also invite Professor Shibasaki Ryosuke, the Director of Center for Spatial Information Science, University of Tokyo. And I said it's going to be heavily academia, but we'll get to know why. I'd like to invite Dr. Ignace Gatare, the principal of the College of Science and Technology from the University of Rwanda. And from the private sector, Ms. Naomi Kurahara, the founder of Infostellar. And lastly, representing the Cabinet Office of Japan, Executive Advisor to the National Space Policy Committee, Mr. Fukuyo Takashima. But without wasting time, I'd like to invite Professor Nakasuka to take us through his presentation. You have a few minutes.
Yes. Yeah, can I start? Thank you very much. So, good afternoon, ladies and gentlemen. As the first speaker, I'd like to show something like a lean technology. What is lean technology? And what kind of the satellite has been developed within this technology, and how we can apply this lean technology. So, let me start. Maybe as you know, the satellite has become a very, very important social infrastructure. For example, this optical satellites, remote sensing satellite, like a Japanese AROS, Daiichi, can take a picture of the very detailed ground. And also, sometimes these pictures are combined to provide a 3D map like this. So this information has been used for the many, many applications like disaster monitoring, agriculture field monitoring, and so on. If we have a synthetic aperture radar satellite, then we can capture the Earth images even during the night and in bad weather. And also it can detect a millimeter movement of the land. And also the communication satellite on the geosynchronous orbit can provide a broadband communication between the sky and the ground, and also it can provide a broadcasting service to the ground. But the problem is that these satellites are too big and also very, very expensive as well. So this has a very big problem. This satellite costs more than 300 million, and a development time would be more than 5 years. So only the big government can enjoy the fruits of space, and the utilization of the space are very much limited. These are the common problem all over the world. Fortunately, very, very small satellite, like a less than 100 kilogram satellite, have been appearing, which are changing the world. So maybe as you see, not only the education, but also many, many applications have appeared using these satellites. And the main active player, the university and the venture companies. And it can also be developed by the emerging countries as well. So these are now changing the world. Why this kind of the game change has been performed by this lean satellite? So these are the reasons. It's very low cost, will lead to new missions, business, space sciences, which has never been realized using the very high-cost satellite. And it introduce new users, not only the big government, but also the companies, universities, or emerging countries as well. And it can be used as educational tools. Also, the short life cycle is another very important characteristics because, for example, it can provide more iterations possible and also early return of the investment. This is very good for the business. And why this kind of the characteristics occur in the micro, nano, pico satellite? This is because it is very simple and the transparent satellite system. These are the key characteristics. And let me briefly show the activity of the University of Tokyo, our university. We developed the world's first CubeSat in 2003 and launched successfully. This satellite has been, survived in space for more than 14 years. And starting with that, we are developing the total 9 satellites, and 8 of them were already launched into the space, including the space sciences, space exploration, or Earth observation, and so on, and or even the communication satellite. And let me briefly show some example of the satellite. So this is a Hodoyoshi 3 and 4 satellite developed within our laboratory, which was launched in 2014. And these target cost is something like this, $3 million US, and the development time was within 2 years. And these are pictures taken by the satellite, looks like this. 200 photon ground resolution pictures include some, image of the smoke. So in this way, even this 60 kilogram satellite can monitor the disaster. And so this is a 40-meter resolution camera taken by Hodoyoshi 3. Maybe within this, we have some area, image of the area which are covered by the tsunami in 2011. So in this way, we can use this satellite for the disaster monitoring. And 6-meter resolution looks like this. Maybe as you can see, agriculture field can be monitored one by one. And also some landslide may be able to be detected if it occurs. And the Axel Space, the startup company from our laboratories, are now developing the GRUS constellation, 30 satellite constellation to be developed by 2022. Why such kind of the big number of satellites are required? In order to achieve the everyday observation of the land, we need a 30 satellite. So this is called the Axel Globe concept. And so these technologies are based on the successful Hodoyoshi 1 satellite, like these pictures. Another very important utilization of the satellite is to get a very weak signal from the ground. If you put some sensors on the ground, and this sensor has a transmitter, then the ground data can be sent to the sky. And when the satellite flies over that area, the satellite can collect these data. It is called the store and forward mission. And the key point is that how we can reduce the required power from the ground. And we successfully implemented the 20 milliwatt transmission, and which was implemented on the 3-kilogram Tricom-1R satellite and has been tested into the space. So this satellite was just launched 2 months ago. And the store and forward and the camera experiment has been successful. And even the 20 milliwatt transmission from the Rwanda was successful. And now we are modifying the design of this satellite so that it can be easily and very reliably fabricated. So we would like to distribute these satellite kits to the many countries so that many countries can develop their own satellites. And even the deep space probe can be possible. So this is a current project performed in my laboratory called the Icarus to target to the Earth-Moon Lagrange point like this. Even the deep space experiment can be possible. So in addition to this kind of the satellite project, we can provide some educational support like this kind of the e-learning system and some hands-on training like a CANSAT experiment and also the microsatellite development support. And also the launch will be supported by the Japanese JAXA by using the ISS like this. Okay, let me summarize my talk. The lean satellites are making a big game change in the world. And the consideration of the affordable remote sensing satellite like costing 3 to 5 million US dollars can take images of Earth with high frequency. And 3 kilogram size, very low cost, around 200,000 US dollars. So underwater satellite can be used for the collecting the ground information. And also this development of GIS satellite can be used for the education as well. So now it's time to start the actual satellite development. Thank you very much.
Well, thank you very much, Professor Nakasuka. I think, yes, it can be developed, but then what? Let's hear from Professor Shibasaki. Tell us how can these technologies be combined with the classic, or what we now know as IT and ICT, to actually solve problems that are facing humans.
Okay, thank you very much. I'm Ryosuke Shibasaki from University of Tokyo. Actually, Professor Nakasuka talked about the small satellite, and you could see there. And actually, I add one more. It's, as you know, actually, it's another small device, mobile device. So then, actually, in order to read such kind of green satellite technology or space technology to the actual applications, probably we needed to combine something and to complement some of the limitations of the satellite data. And this is a picture that actually we are now looking at. And with the development of the satellite technologies, we could have a very good space infrastructure. We could map, we could observe the ground surface, and also actually we could, let's say, determine the exact location, and also we could transmit the data. And on the ground, you could see another small devices, a kind of green technology that is very much popular among us. And then, actually, from such kind of devices, we could collect the data on the reality on the ground. So then, by combining both, I believe that we could develop. What's happened? Oh yes, a kind of, let's say, very innovative and diverse social benefit services. And as you know, actually, the number of the handsets is more than almost similar to the world population. Everyone has such kind of mobile devices. And actually, such kind of mobile devices tells us a very exact data on what is happening on the ground, something like a disaster, because tsunami or the earthquake is one of the most important, actually, the disasters for Japanese. And in 2011, we have a kind of earthquake and tsunami, or sorry, again, I'm not quite familiar with using this. But anyway, at that time, Tokyo is a little bit far from the epicenter, but the railway systems, the transportation system stopped for safety. So everyone have to walk from the office to the home. So then, actually, through the mobile device data, we could very easily, actually, visualize how the people behaved on that specific day. And actually, this is not the very special data collection experiment. The similar kind of data are collected every day, of course, 24 hours, and anyway, 5 days. And even nowadays, actually, those data are collected on the real-time basis. It's a kind of location data from the mobile devices. And you see, this is Tokyo, of course. Many people go to the center of the Tokyo for commuting. And that is a Friday. And actually, at around 2:46 p.m., we had the earthquake. And all the transportation system stopped, and everyone have to walk like this. So then you see a slowly moving dots. Actually, individual dots correspond to the individual handsets, sending the GPS data. And actually, the data are collected on the real time, anyway, kind of basis. So by looking at that, everyone can share how, let's say, significant, how serious the people, the problem that the people has. And also, probably you may start thinking about what you can do for them. And another, of course, the social issues, a kind of disaster, for example, here. Typically, there are many social issues ranging from transportation, disaster, but anyway, some kind of public health. As you know, the virus or some sort of the, let's say, germs or whatever could be sometimes conveyed by people. In case of the Ebola, of course, the virus is conveyed by the people. So then, actually, we are invited to analyze the movement of the people in Sierra Leone, Guinea, Liberia by the United Nations, ITU. And you could find a kind of detailed report in the ITU website, Big Data for Development. So again, compared with Tokyo, the people flow is very sparse, but nevertheless, you see that the people actually steadily move to the, let's say, coastal regions. You could see Freetown, a capital city. So then, actually, once you grasp and understand this kind of people flow, when something happens, you could make a much better informed decision. Let's say, stop the transportation or anyway, something like this. And we started some sort of the experimental data analysis, of course, here in Africa. I'm not quite sure whether there are anyone from Mozambique. This is obvious, Mozambique data. It's a southern part, and Maputo. And actually, we have analyzed some of the mobile phone data to support kind of, let's say, transportation, planning, and also the management, focusing on road. So at the first, we try to estimate a kind of origin to destination matrix. That is the very basic indicator of the transportation demand. And also after that, such kind of data have collected with the JICA study that is collected through the household interview survey. It's very, very expensive, of course, and cannot be repeated so often. But as long as we use mobile phone data, it's so easy. So then, in Rwanda, we are now making a lot of effort with RURA to establish the data analytics center using the same kind of data. But in parallel with that, we are now encouraging or promoting the collaboration between Japanese company and also the Rwandan company. So this is the results. So you see the entire Rwanda is now being covered by a kind of GPS data, obviously from the vehicle. So then you could see how the travel speed of individual links may change over time during the day. And so far, we just talk about what kind of data is available from the mobile devices. But in order to understand the people flow, probably, for example, the left-hand side and the right case, both are a kind of just a crowd or a kind of concentration of the people, but the context is quite different. So anyway, in order to understand such kind of differences, we need a map. So then, actually, lean and open space technology is really important. So we started with, let's say, making some sort of the maps of the city expansion. We're using the open satellite data. And nowadays, we are now making preparations for handling kind of high-resolution data from, let's say, Hodoyoshi or Gruz, or anyway, such kind of high-resolution satellite data to extract the houses. As you know, cities is covered by OpenStreetMaps or voluntary maps. But in the rural area, those areas is very important, especially for malaria, actually control or whatever, but there is no good maps. So then using a kind of deep learning or whatever, we could make update or revise a kind of digital data or digital map data so easily. So then this is the conclusion. Let's drive inclusive development and achieve SDGs with lean space technology and mobile big data analysis. Thank you very much.
Thank you. Thank you very much, Professor Shibasaki. And yeah, this is good. Africa wants to jump on such opportunities. But then, do we have the capabilities, Dr. Inyas Gatare? Our universities preparing our young people to be able to do this kind of, to engage, develop solutions, or even, although Professor Nakasuka has already said that these things can be done here, are we ready?
Thank you very much. I think, first of all, we would like to thank the team, the research teams from Japan, from democratizing this space technology. We all together remember the Apollo 11 mission and other mission we saw in Ariane for Europe. It was a dream, saying this something difficult to achieve. I know that the African Union has also the agenda of launching a large-scale continental space program through a very clear strategy. But as Alex said, we need capacity. And if we could see the prototype there, is because we have a professor, we have students, we have people who do research and multidisciplinary research. You see, big data can be connected to space science. At the beginning, it's very difficult to understand, but you could see how discipline can be connected. As far as you are concerned in Africa, one of the major challenges is doing research, applied research, but also training engineers who can really take the things and make them happen and integrate programs. So we know that we have an academic program in Rwanda, for example, the College of Science and Technology, which is one of the College of Science of the University of Rwanda, trains engineers and scientists. So for us, we see it as an opportunity. We have a traditional program like mechanical engineering, electrical engineering, but also other sciences like civil engineering. So by working together with the advanced team like the Japanese team, there is an opportunity to customize our program and revise them, to align them in order to make them relevant and embrace this new technology. Yes, we are ready to work together by building on what we have right now. The point we want to raise here is also to strengthen the academia, private sector, and government partnership. We know that we have a regulator like a Rwanda Utility Regulatory Authority, but we have the Ministry of Information Technology and other players, the industry, who could work together in order to make this space technology, particularly this affordable technology, right on the campus. We have young people who are willing to learn, and actually the presentation we are seeing here, we've been privileged to have this presentation at the campus. And we thank very much the team from Japan. We could see how young people are willing to learn. So I think if we take these programs and we embed them in the traditional curriculum and with clear goal, here we are talking about SDGs, so we can link those programs with these goals. For example, we have the African Center of Excellence in Data Science. This is a center which is just recent, 1 year, less than 1 year of operation. We can link it so that they work with the team in a collaboration framework so that they start analyzing this very data. So the good point here, it's multidisciplinary, from health, agriculture, environmental observation, earth sciences. All those disciplines can be supported by this technology. Yes, we are ready, but we need to put in place the soft infrastructure, which is the human capital development. Thank you.
Thank you very much. I want to bring in Naomi, who's an entrepreneur, but also, as I understand, was one time in one of the labs from Professor Nakasuka's lab. And the question here for me is, how do you transfer the technology and the research into enterprise, into entrepreneurship? How have you done it? What is InfoStella and what are you doing?
So the InfoStella is a space startup based in Tokyo. I was in academia, but I started my company because I thought that technology should be used for changing our lives, our technology, our environment. So I started to have an interest to do so. And could you start my video?
Stellar Station is a platform that enables antenna sharing for satellites. The advantage is that free antenna time could be shared. Stellar Station automatically coordinates communications with nearby satellites.
Are you going to present?
Satellites are usually paired with a single antenna on Earth, limiting the communication time to only 40 minutes per day. However, by installing the Stellar Station platform at antenna sites in other regions, free time at those antennas can be shared, increasing the communication time available to satellites. We aspire to make real-time satellite communication a reality in the future. Satellite Antenna Sharing Platform. Stellar Station.
So this is a sharing platform, satellite communication antenna for ground side. So the ground facility it is not cheap, but if you share your system for others, you could get a revenue. So we want to provide a solution or a way or a mechanism to raise a fund or money to sustain your satellite activities, your satellite space development in your countries. So that is our business.
Thank you very much. If I hear you right, you're saying that currently, if I was to install a ground station system, it will cost me a lot.
Yes.
But if I'm to borrow from the sharing economy, the model of sharing economy, I could use your Stellar Station to do this kind of thing.
Yes.
And Africa, I understand that you've been doing some work already, experimenting in some countries. If you could speak to that, please.
Yes, another Japanese team is providing a technology transfer program for Ghana and Nigeria, and Infostra supported to operate their satellites.
Okay. Thank you very much. The African Union has space program or space strategy, not space program, but space strategy, has an emphasis on international cooperation and partnerships. From the Cabinet Office or from the National Space Policy Secretariat, Mr. Fukuyo, if you could tell us, do you think that Africa has a chance? Is there any way that we can collaborate with you guys?
Yes, thank you, Chairman. In Japan, also, almost 10 years ago, Japanese space policy also focused on the science technology and the development of the space technology infrastructure itself. But now we are changing our policy also for not for just development of space infrastructure, but also for the more utilization. And 2 years ago, Japanese government also published the guideline for the space cooperation for international cooperation for space technologies and space utilizations. And now our Japanese government is Cabinet Office. They established the task force for the international cooperation, and we established a working group for the SDGs, Sustainable Development Goals, using the space technology. With these guidelines, now we are promoting the building the capability for the developing countries, and also promoting the utilization. And now with these lean space technologies, we can realize now, for example, not just big countries, for small countries and the university and the startup companies can make their, for example, satellite or their ground stations, and we can cooperate with these technologies. and not just for the spacecraft, but also using the space data and for example, other IT technologies. Combination with it, we can accelerate or promote more solutions using the space and spatial technologies. So, and we are already starting some new project with include not just Japanese government, but also with universities and industry sectors. So already we starting with, for example, Professor Nakasuka mentions like Axel Globe and Q-Tech Infostellar. We already starting receiving the young engineers and students for the new spacecraft engineering technologies. Yeah.
Thank you very much. Thank you for people that are here. We've heard from the floor, from the panels, but I want to bring in someone from the floor, and it is the Director General of the International Telecommunications Satellite Organization, Mr. Patrick Masambu. I don't know if you have a microphone close to you. There is supposed to be a microphone. At the front. Yes, you can come to but they're bringing it to you. Over here, please. Yeah.
Thank you very much, Mr. Moderator.
From a regulatory standpoint, you've seen these lean space tech and all the excitement that may be there. Should we hold our hopes high?
Well, let me say that I think from the point of view, a couple of comments.
Yes.
One is that I think the need and value that ICTs add to sustainable development is now pretty well understood. I think many governments realize that there is linkage between ICTs and sustainable development. But I think the role that each of us, whether it's at individual level, at business level, or at institutional level, what role we can play to ensure that that linkage is actually implemented remains a challenge. Now, obviously, the question you would ask is that what are the gaps that we need to put in place, that we need to address in order to ensure that we bridge that gap? Personally, I think that for sustainable development to take place, we need to ensure that the policies, regulations, institutions, and legal frameworks are in place. Today, given the examples which have been stated here, first, in terms of time frame, it's only 10 years ago that a lot of work started taking place in Japan, an industrialized economic power. If you translate that into some of our countries on the continent, obviously it means that I think the starting point is that before we move, do we have the institutions, do we have the policies, do we have the regulations in place to ensure that there is sustainability in terms of promoting that technology? I think, talking from a practical point of view, I know that, for example, many regulators do not, in many cases, take satellite technology as being priority in terms of provision of ICTs. So even the very natural starting question is, do we have plans in the nations that put the various technologies at par? If you're looking at broadband, I'm just giving that as an example, in terms of developing broadband plans, do we provide the ability to look at both satellite, fiber, and mobile technologies on the same level of footing in terms of planning? Because I think that is basic in understanding the value that satellites bring before even moving further to areas which are experimental and innovative. But that having been done, it means that I think if you identify that, then the right institutions have to be put in place. The right policies have to be in place. The regulations have to be in place. Obviously, many people say that innovation survives best where there's no regulation. But for long-term sustainability, you need to have the institutions, the mechanisms, the laws to ensure that that is done at the level of investment. And so my key point, I think, would be to say that even today, as mentioned by one of the colleagues earlier, at the African level, there is an African space policy which was adopted in 2015. But how much of that has been domesticated? How many countries, governments, ministries are aware of that policy which was approved 2 years ago? That is the starting point, domesticating the national, the regional policy into national laws and policies. once you have done...
If I may interject, as it's still on, aren't we at risk of waiting for regulation, waiting for plans, when actually things are moving and there's these lean technologies we can kick straight away? We've already seen examples from disruptive companies. Could it be that actually these type of technologies are disrupting even the regulatory environment that may not be ready?
I'm not suggesting that you should stay behind and do nothing. I'm saying that you need to do the two things in parallel. What I was going to come to say is that I think as we take them up, we need at the same time to be doing a lot in terms of policies, institutions, and legal frameworks. Because for long-term sustainability, that is important. Number two, you need to have a lead champion. Here we have the universities. But at the end of the day, I think the students will ask, after only 1 year of school, to say, where do I fit in within society? Where am I going to pick the chance? Is it me alone as a person? Or is there a mechanism of being able to benefit from government support? The innovation hubs, the innovation policies and funds that are being put in place by governments, that is one area where you could say lean technologies ought to be part and parcel as a component of where the innovation is going to, because it is actually an innovation. And I think from that point of view, then, the other issue you'd want to look at, what are the partners? Rwanda is partnering with Japan, but is that something that is recognized by all countries? Shouldn't there be intervention at the top level, at the regional level, to ensure that as you domesticate the policies at the regional level, at the national level, those partnerships are being developed? So I think there are a lot of questions to be asked.
I want to bring in Mr. Lipsky. Just on that, from that point of view, from the industry perspective, Eutelsat, I know you've been an entrepreneur yourself. Is there an industry from all your angles and the hats that you put on?
Thank you very much. I actually, yes, I was an entrepreneur, and now I changed my hats, and now I run an international organization which oversees one of the biggest geostationary operators from a certain standpoint, which is the public policy standpoint. So when I look at this marvelous development of this proliferation of this low orbit initiatives and so on, entrepreneurs like Madame either putting their own spacecraft in space or just finding new ways of, in this case, in telecommunications field. I have a couple of thoughts that, first of all, in terms of building all this capacity, we must not forget about the managerial and human dimension and the multifaceted training environment or training ecosystem, which is kind of full of contradictions, because first, most of the people who are, and this is also experience my country, which is Poland, which is a country in Europe, but it's kind of new to this space thing. There's kind of contradiction, because of one hand, the world is full of enthusiastic, young, bright minds who want to create things. On the other hand, the business environment is such, and even if the satellites, those nano and micro, are cheaper than the big birds up on 37,000 kilometers, it still requires capital, still requires organization, still requires many things to succeed. So what I'm saying is that all of us who at one point of time either created such ventures or teach young people, or mentors to young people, must not forget that other dimension, which is not maybe so sexy as a pure technology, but as this new industry is developing, that we need to equip people with know-how also in the field of management, in the field of capital acquisition, and so on. So this is extremely important, and this is also a challenge for all those young firms and young people to understand it's exactly what they want to do, right? Because one thing is to have, an important thing is to have a clear objective. Do I want to contribute to pure science? Do I want to make money out of it? Or kind of something in between, right? But sometimes, and I'm somewhat surprised that that people don't stop for a moment and don't ask themselves that that kind of question. When they do, and when they stipulate this, or define this, there's a whole world of cooperation out there. There's a cooperation, and this has already been mentioned, at the high, like state-to-state level or university-to-university level. In Europe, where I come from, there's obviously European Space Agency, which has all kinds of wonderful programs, also some of them aimed at Africa and so on. But what I'm trying to say, and maybe this is one thing that I would like to leave the young people who are either already in this field or thinking about it, is to create their own network of contacts and their own network of information exchange. Whether it's in sending, new great small satellite with a great mission, or just, as it has been said, finding a new way of analyzing all the data that's available, that's another thing. But the chances are that somewhere else is somebody who's trying to do the same thing, and maybe if you pool the resources, will be stronger.
Thank you.
So that's basically my take on it.
Thank you very much. I'd like to bring in Rashad from Other Cosmos. You're CEO of Other Cosmos. That's what the chairman. That's what it says on the on your brief. But you can tell us your angle from Azerbaijan.
Thank you, Mr. Alex. I'll make a little correction.
Yes.
I am advisor to the chairman of Other Cosmos.
Okay. Thank you.
Unfortunately, because of a very important arrangement, he had to fly out today. So I will be speaking on his behalf and on behalf of Other Cosmos. First of all, it was very interesting to listen to everyone. And it's always unique to speak at the end, because very important messages were sent. Very strong views were already made here. With Professor Nakasuko, when he talked about lean satellites, education and satellite development, that is very important. With Professor Shibasaki about data analytics and mobile data, that is not only the future, it is the present already. With Dr. Ignace, was very interesting, because for me to hear what the real demand is, what the vision is, where Rwanda and African continent, nations of African continent are heading. That's very important to know, to define your goal, to have the vision, and then to work toward that way. I remember yesterday at the panel, one of the panelists mentioned that you cannot get lost if you don't know your direction. So you need to know the direction. And also Mr. Yukimatsu about the policy, cooperation, the spacecraft and space data, with Ms. Kurahara about sharing ground control infrastructure. And of course, Mr. Masambo, he made great points about the values and the gaps. And I would like to continue what Mr. Piotr Dmashevsky said. Network, G2G, and having clear objectives. You need to define what you need first. Other Cosmos is a pure example of success. It was established only in 2010. And in 2013, we launched our first telecommunication satellite, Other Space 1. In 2014, we launched our first high-resolution low Earth observation satellite, Other Sky. This year, we're launching our third, however, second telecommunication satellite, Other Space 2. So from establishment date of 2010 to today, in 8 years, our fleet has already 3 satellites. Last year, we established an R&D center, and that is what all of you said, human capacity, capacity building. That is very important, because just being a satellite operator, an engineer is not the challenge anymore, because you just follow standard operation procedures. You just go on with the what is written, with the rules and regulations and guidelines. But R&D center opens a new challenge. It creates a new challenge. You get into a problem, and then you try to solve it. It opens many doors for collaboration. So
talking about collaboration right there at the R&D level, and the collaboration, especially that we want to build capabilities in Africa. Is there space within other cosmos for African countries to collaborate with you on the R&D?
There is not only space in R&D. I am looking at motto of Transform Africa Summit. It's connect, innovate, and transform. With our telecommunication satellites, we have very strong C-band coverage over African region. And with second telecommunication, we'll have standard KU band. So we can connect African continent. We can innovate, we can collaborate, not only in R&D, but in training, in human capital development. We can have different exchange programs. We can share our knowledge. And we can relate to African nations because we re-established space industry only in 2010. So we have gone this road. As Mr. Dmowski said, somewhere someone is probably doing the same thing.
Yeah.
Someone probably has already done this, has passed through this. So we know all the pros and cons. We know where we can fast forward, where we can focus on something, and where we don't need to spend much energy on. So not only in R&D, in remote sensing with data usage, with satellite imagery, with space applications and space technology, on all the fields, in all the sectors and directions, we're ready to cooperate.
Thank you very much.
And we would like to become a very trustworthy partner of African nations. Thank you.
Thank you very much. I would like to open up to the floor 2 questions because we already run out of time. But if we could have a microphone on the floor for anybody with a question. There's someone here in the corner. We'll take both the questions and then we'll answer at once.
Thank you very much. I want to ask a question on the...
Please tell us who you are. So that
Wilson Kagabo is my name. Wilson Kagabo is my name. I want to ask on the way to manage or deal with the decommissioning of satellites. You know, we're talking about, let's put more satellites up. They're going to be cheap. They can be used in our day-to-day life. So when they get decommissioned, when they end their life, you know, basically they go to the grave, how do you deal with that amount of debris or trash that we're creating in space? What thoughts are you giving this particular element of decommissioning satellites, especially when they become too cheap to make? A lot of people will be launching them. A lot of people will be putting them to space. Before, there were a couple of companies doing that, you know, heavy investment. But now, if it becomes very cheap, everybody's going to put up a satellite. How are we going to deal with the debris after we decommission those satellites? Is one question I want to ask. The second one is that as we think about being cheap, I can talk about CapEx being cheap. You know, you need less money to put one in space now, but what about maintaining it? What about if we compare the operation of that satellite to provide the kind of services that today we're getting with other means of technologies? Are we really making a profit there, or it's the same? So I want your thoughts basically on the business model and whether it's good value for money.
I guess that it goes to Professor Nakasuka because it's the debris thing. Is there, I know he asked 2 questions, but really it would be unfair to take 2 questions from one person. So if there's any other person with a question? No questions? Going once? Yes, in the middle.
Yes, my name is Tomo Naito from JICA, Japan. Just a very simple question. What kind of the request to the panelists for us to learn your message? With the comment from the floor, I personally understand that there are many things we really have to be prepared in order to automatically jump into this the new technology apply for application. For example, the commitment Africa, in terms of Africa, commitment is already there. African Union have the clear strategy. Technology, it's already there, lean technology, and Stanford and so on. It can be applicable. But on the other hand, as some of the other commentators mentioned, that the legal framework, institution, human capacity aspect, all those things still have to be really started actually. So my request, or the question to the panelists is that what kind of message are you going to provide to especially to the partners who are actually participating in this floor, especially from the African countries? What kind of things is the most important things African countries should do or should tackle in coming, let's say, 3 years in order to reach to this very special and very actually important application? Thank you very much.
Thank you very much. If we could take, I think we can get an answer from Professor Nakasuka, and we'll also hear from Fukuyo on the question on that Mr. Naito has asked.
Okay, thank you very much. So as to the debris problem, as you said, that it is becoming even severe recently. And the important thing for the satellite developer is to make it down to the atmosphere after the death of the satellite within the 25 years. And if all the satellite is going down to the atmosphere within the 25 years, then enlarge of the number of the debris will not happen. And then we can keep the space safe. But the very big problem is that still we have a very big debris is remaining in the orbit, like upper stage of the rockets of the big satellite. And that kind of the big satellite has higher probability to make a very big number of the debris than the smaller satellite. So we should remove such kind of the big satellite as soon as possible. And there are several research from European Space Agency, American, and also the Japanese JAXA to remove, how to remove it into the atmosphere. So I think that kind of the two things is required. That is not to be debris and how to remove the debris. So we should consider these two things. Is it okay?
So if I could get concluding remarks, and if you want to get an answer to answer Naito's question. Yes, please.
Okay, anyway, thank you very much. I really enjoyed the discussion and comments. Actually, I have two kind of comments or kind of ideas. The first one is kind of possibility of the contribution of Africa in terms of the R&D. For example, Mr. Alex repeated several times. But actually, there are so many topics for the R&D, and also those topics are really necessary. So, for example, when we start writing or start some sort of the research, we are requested to review the papers, existing studies, avoiding inventing wheels again, of course. And yeah, probably some big, let's say, companies have already developed or invented some actually telecommunication infrastructure, technology, hardware, whatever. But apparently that is not enough. Once the data transmission becomes easier, then the new challenges, new applications actually will emerge. So then that requires a new R&D. So what I want to say, probably the African young generation should make a full use of the existing results and R&D achievements, and then run as fast as possible forward and find out the new research topics. And there are a lot of frontiers. So I believe that there are a lot of possibility of the future collaboration. And the second part is governance. So far, let's say in terms of the telecommunication world, in the very old age, the big national company actually developed made a lot of investment for develop a kind of telecommunication infrastructure. Develop a kind of optical fiber or metal actually lines or whatever. And also that is a kind of centralized, sometimes a planned expansion. But in the era of the internet, the individual router or actually such kind of devices is just very freely connected, and finally it forms a very big kind of network. And it's actually nurtures a lot of interesting applications, new research topics. So I think that even the space infrastructure is now shifting from a kind of centralized planned development of space into the more autonomous, distributed, and probably regulations may not be directly handle the kind of results, but the kind of behavior rules. Yeah, of course, even in the nowadays, internet is now challenged by fake news or whatever. And but anyway, I believe such kind of waves or trend is now, I believe, happening in the field of the space infrastructure development and also utilization.
Thank you very much. I'd like to hear from Dr. Ignace in your closing and the closing remarks.
Thank you very much. I think I will go back to our core business of training. I'm seeing any initiative we undertake, the human capital gap will be a bottleneck. So as I said in starting, we need to adjust our curriculum. We need to think differently in terms of the way we interact with our students, particularly the innovation side. So we are glad that we have partners, but at a continental level and at a national level, if there is a clear goal, we know that we have a national strategy for transformation. So, and it's connected to SDGs, as we know. So once those goals are well defined, and they are already well defined, it's up to us, academic program offers, to adjust and to put a correct environment so that our students are doing things, research, but also capacity building programs which empower them to be ready to embrace this new technology. So yes, we are ready, and so we are glad that our partners from Japan are ready to share some knowledge and do knowledge transfer. So it's up to us to adjust our curriculum. So at the continental level, again, I like the question about the readiness and commitment of Africa to define its own strategy. I think for the gap of 3 years, as he asked, we need to agree on the major goal at the continental level and integrate them on a national strategies. And then the academia and other partners at a national level, continental level, even global level with the partners from Japan and elsewhere can go and implement sub-program in their day-to-day planning or at a national or local level. Thank you.
Thank you very much, Doctor. Naomi, we saw in your video, we saw the US, the UK, and Asia. What's next as an entrepreneur? We don't see a dot somewhere.
So actually, the InfoSera, we are trying to build our testing station in Rwanda in summer. So we hopefully we will start soon the sharing business in Rwanda. Yeah.
Thank you very much. And Mr. Fukuyo, international collaboration, Japan is open, but are you willing to let African countries that are working also with other partners, how do we get other cosmos into this kind of collaboration with you?
Yeah. Thank you very much, Chairman. And I'm now participating in this session as a executive advisor for the National Space Policy Committee, but I'm also the professor in the university, and also I'm founder of the one association for the capacity building with space development and new utilization of the new solutions with space technologies. And as a founder of this association, we call the Space Edge Lab. Now we are already starting this our challenge for the capacity building and the new approaches. And so for us, it is very simple. My message is that we would like to start this cooperation with capacity building, not just capacity building, with promote more incubation, innovation with African countries' peoples, and not just for the, making the small satellite, but also already we are using this new space, small spacecraft for the real use, for the real solutions, for the new, for the, some global issues. And already we starting our capacity building program with Rwanda for the utilization of this space satellite, small satellite communication network for example, water resource management and some new project for the agriculture. And today also our partners also there are there. And so we would like to start, and we would like to invite other countries and other young engineers, and not just for the African countries, but also other partners also. Yeah, thank you very much.
Thank you very much, and a big round of applause to our panels. Thank you very much. And everyone who's here, they are models. These are not smaller size of a satellite. Actually, these are the real thing. It's just the engineering models. You can come and check them out after. But I would like to say that this ends our panel right now. And we're going to go forward, network, have a chat with whoever you want to chat with. If you want to ask them questions directly, feel free. Thank you very much. Have a good evening.